Alright, so hello, welcome to our fourth lesson of our HBL. Now, you would have learned about simple distillation the day before, so now let's put everything into practice. You would see this question on page 11. Can you take time to actually fill in all the different labels? You can pause the video here to do so. Okay, so let's go through the questions or filling the blanks of the diagram below. Now, this is a simple distillation setup. So you must be familiar during a WA tool to be able to label certain of the apparatus. Okay, so let's look at number one. Number one is actually your round bottom flask. Okay, number one will be your round bottom flask. All right, number two will be known as your boiling chips. And very quickly, let's just do a brief revision on what the purpose of your boiling chips are. Okay, now the purpose of your boiling chips, this boiling chips here, is to ensure good, smooth boiling. All right, so that's why we put the boiling chips. Now, can you guess what is number three? Yes, you guessed it right. It's actually where the Bunsen burner should be. So that is why we say that the heat is in this area. Okay. All right, let's move on. Number four will be your solution. This is the one that, this is where you want to obtain your pure solvent from. All right, and number five would be something that you're very familiar with. It's your thermometer. Now, the thing about your thermometer is your thermometer must be placed, all right, at the side arm leading to the distillate, and it must be side by side. This is to ensure that you're actually measuring the boiling point, all right, of the solution that is going to be evaporating. So you cannot have it too low, but you must have it slightly higher so that it accurately measures the boiling point. All right, and then number seven, this whole number seven is known as your condenser. Now remember, the term condenser actually means that it will allow condensation of the water vapor. Now, in order for the condenser to allow condensation of the water vapor, it needs to provide a cooler environment, and therefore, okay, the water direction is very important in the condenser. Okay, because the water must come out from the bottom. The water must go in from the bottom so as to fill up the condenser completely. So you want to completely fill the condenser. Now, if the water, in example, if the water was to enter from the top, then whatever water that enters will also flow out, and therefore the condenser will not be filled. So the water cannot enter from the top, it must go out from the top, so that the entire condenser will be filled to provide a cool environment so as to allow your vapor to condense. All right, now when your water vapor condenses, all right, it will form water droplets, and these water droplets will then slide from the tube inside the condenser into the beaker, and it will be collected as your distillate. Now, Miss Lee has taught you why do we use the term distillate, because the term distillate comes from the term distillation. All right, and since the water droplets have to slide down into the beaker, that is why the condenser has to be slanted. Okay, so let's look at blanks 9 and 10. So 9 will be your beaker, 10 will be your distillate. So you can record at the side how many you actually got correct. Now, a few things that you need to take note about distillation will be present at the bottom here. So there are some common questions, all right, that you will need to know. But firstly, let's first revise. Your simple distillation can be used to extract pure water from the following: seawater, salt solution, which is a mixture of sodium chloride and water, and sugar solution, which is a mixture of sugar together with your solution. Okay, your water. Now look at some of the common questions that you will need to know, and it is found on the bottom right hand corner of this picture over here. Okay, now same thing, we ask why must the condenser be sloping downwards? Remember, the condenser must be sloping downwards so that whatever water vapor that condenses and form water droplets will be able to slide down into the beaker to be collected as, yes, I can hear you, distillate, all right, in the process known as distillation. Now, why must the water enter from the bottom and come out from the top? Good. That is to allow the condenser to be filled completely. And the condenser must be filled completely so that it is an efficient cooling system. Okay, now if it is half filled, it will not be able to completely cool the water vapor, and therefore the water vapor cannot condense fully into your droplets, and therefore your distillate may not be collected completely. Now you may see over here, number 3. How can the setup be modified if a volatile liquid is collected as a distillate? Now, a volatile liquid is a liquid that is easily evaporated. So if let's say the distillate over here is a volatile liquid, that means this liquid is able to evaporate at very low temperatures. How can you modify this setup so as to ensure that you can collect your full volume of your volatile liquid? That means that you will probably need to keep this beaker at a colder temperature, okay, than room temperature. Alright, so you guessed it correctly. You might probably have to put this, okay, inside a cold water bath so that the distillate doesn't easily evaporate to give you vapor. Since a volatile liquid um, can be easily evaporated to form vapor, you must keep this beaker in a cold environment so that the distillate can remain as a liquid for a longer time. Okay, and of course the fourth question we asked just now, why must the bulb of the thermometer be side by side to the, alright, side arm leading into the condenser so as it can measure the boiling point of the vapor accurately? Okay, so this summarizes our um, third it summarizes our fourth physical separation method, which is simple distillation. Now let's move on to our last physical separation, known as paper chromatography. Now paper chromatography is actually quite a fun technique, and if you can turn your attention to the right hand side of your definition on page 11, you will see a piece of filter paper with a paper clip in the beaker, and you will see 4 columns of colors. Now paper chromatography is very effective because paper chromatography allows you to separate small amounts of substances. Now the substances that you're usually separating are usually colored substances, and that's why we say pigments. So you're trying to separate the colored, okay, you're trying to separate the colored components from the mixtures. So you're trying to give rise to colored components from the mixtures. And the good thing about paper chromatography is that you are able to separate very small amounts. You do not need large amounts, okay? It can be carried out using very small amount of substances, and you can actually use the technique to separate substances that are found in very small amounts in mixtures, because it's quite a sensitive technique. All right, so paper chromatography makes use of the fact that different substances, okay, dissolve at different extents in mixtures. Now, what do you understand by they dissolve at different extents? All right, they dissolve differently in a mixture. That means if I have, let's say, substance A, it may dissolve very differently in water compared to substance B. Okay, so you guessed it right. um, chromatography is actually referring to the solubility of substances. That means it plays around with the solubility of substances because different substances have different solubilities. All right, and as we go along, later on, we will discover why solubility is such an important concept in chromatography. But before we do that, maybe we can watch an animation on the entire process of paper chromatography. Now remember, you are trying to separate the pigments. That means you hope to see colored dots on this filtered paper. Okay, so let's watch this short animation. You take a pipette and you drop 2 drops of the colored mixture onto this line here on the filter paper. You may want to ask yourself, what do you think this dot is going to do? Now you're going to put this in a beaker of solvent. Notice that the line is below that. So you notice as the solvent actually moves up the filter paper, you can see something happening here. You can see a separation of the dots, and you can see that the dots are actually moving up the filter paper. And you can see 2 dots. Now at first you started with only 1 purple dot. Okay, so let me show you here. At first, you started with only 1 purple dot. This was a purple dot. And then after that, you realized that the purple dot actually moved upwards, and you started to realize there was a second dot. And this second dot is actually a blue color. That means the purple dot is actually made up of this purple dye and this blue dye. So my question to you is this purple color pigment that you first started out with a pure substance? If it's a pure substance, then you should only see one dot. If it's an impure substance, then you will see more than one dot. That is why you have two dots here, right? You have a blue dot and you have the purple dot. Okay, now this entire process is known as paper chromatography. Not to worry, I will explain the process to you in detail later on. But before we do that, let's watch a video to show you the industrial applications of paper chromatography. Okay, I apologize. So let's watch the video again.
Bubble tea, the drink that has captured the hearts of youths in Singapore since 2001. Till today, the chewy texture of the tapioca balls makes the bubble tea unique. This is Paul. He wants to set up a bubble tea shop with multicolored pearls as the selling point. However, there were incidences where toxic chemicals such as plasticizers were found in drinks.
What? You mean the plasticizers which are used to make plastic flexible are added to our drinks, which then enter our bodies?
As a responsible businessman, he sends his pearls to the Health Sciences Authority, HSA, for testing to ensure his ingredients are safe for consumption. HSA provides a variety of tests on food to determine if they meet safety standards of our National Food Authority, the Agri-Food and Veterinary Authority of Singapore, AVA. The laboratory officer prepares samples before testing. The tests will determine the quantity of chemical preservatives and the presence of non-permitted colorings and plasticizers. Laboratory officers also use chromatography to determine the presence of artificial colorings in the food sample. Thin layer chromatography, TLC, can detect a wide variety of colors. Does this seem familiar? It's similar to paper chromatography, which is taught in school. It's easy to see if non-permitted colorings are used by comparing the colored spots on the chromatograms. Now, Paul can make his decision as a businessman. Can he proceed with his plan to sell his product with the multicolored pearls? Yes, he can.
Alright, so you saw that, right? You saw the video and how AVA, an arm of HSA, Health Science Authority, actually makes use of chromatography to determine if there are certain substances, artificial substances. They are also able to identify the type of food colorings, the type of food flavorings, and also to determine if there are any banned substances in an unknown sample. So actually paper chromatography is a very useful separation technique that even today science is still using it. Alright, so let's have a look at what paper chromatography really is. Okay, now in paper chromatography, alright, see just now a spot of ink is actually applied to a chromatography paper. Alright, then it's lowered into the solvent. This solvent will help to dissolve the dye, and then the dye will move up the paper together with the solvent. So just now, basically you saw that this is the solvent and this is the ink spot. Okay, so this is actually, it can be your unknown sample as well. Okay, it can be your unknown sample. Sorry, I'll write this down. Alright, it can be your unknown sample. So what happens is that this solvent is able to move up the filter paper. So remember just now we said that chromatography actually relies on the solubility. Okay, it relies on the solubility of substances, right? And how different substances dissolve at different extents in different solvents. So if this ink spot cannot dissolve in this solvent, this ink spot will not move up the filter paper at all. If the ink spot is soluble, then it will be able to move up the filter paper when the solvent is being absorbed along the filter paper. So let's have a second, let's have a look. The different dyes in the ink will then travel up at different rates along the paper. Okay? All right. So, and over here you can see very clearly, all right, you can see very clearly here that this is the original location of the ink spot, and you can see 3 dots, 1 colored spot, 2 colored spot, and 3 colored spot. Now you would notice that the first colored spot is red, and the second colored spot is green, and the third colored spot is actually yellow. So you would notice that this is the least amount that it can move, this is the second that it can move, and this is the maximum height that is reached by the solvent before this entire paper is removed. Now, what do the 3 dots actually tell you? It tells you that the original substance that you put at the base of the line here is actually made up of these 3 different substances: a red substance, a green substance, and a yellow substance. That means the original substance is actually an impure mixture. Because if it is a pure mixture, you will only see 1 colored dot. You won't see 3 colored dots. Now, um, at the end of this experiment, the different dyes will be separated in the chromatography paper. So you can see that this one dye, this one colored dye, is actually made up of 3 dyes itself. It's made up of a red dye, it's made up of a green dye, and it's made up of a yellow dye. Alright, now the paper that has the different colored spots has got a special name itself, and it's named after the process chromatography. It is called a chromatogram. Alright, you may want to pause the video at this point so that you can fill in your notes and also read through the entire process that we have just covered. Alright, so let's go on to the next part. Okay. Okay, so there are some precautions in chromatography, just like how there are some precautions in simple distillation. Remember, when you have to put in boiling chips to ensure smooth boiling, where you have to ensure that the condenser is slanted, where you have to ensure that the bulb of the thermometer is directly side by side to the side arm leading into the condenser. Similarly, with chromatography, the first precaution that you need to know is that you need to use the pencil to draw this line. Okay, this line that is drawn on the filter paper is usually it is usually done using a pencil and not a pen. And there's a reason why. Now, pen ink may dissolve in the solvent. Now, if you put in the filter paper and you use pen ink and it dissolves, then it becomes unclear where the starting point of the chromatography process is. Okay, so the pen ink might actually interfere with this dot here. So if let's say the pen ink dissolves, the dot also dissolves, and you see you see the separation of the ink, you are not too sure whether the separation of the pigments here is due to this original spot or is it due to this pen mark here. So the best is to use pencil, because pencil is not so easily dissolvable in the solvent. Now usually we use ethanol or water as a solvent, and that's why we use pencil, because pencil is not dissolvable in alcohol or in water, unlike your pen ink. Okay, so that's the first precaution. The second precaution, if you can see over here, what do you notice about the line drawn on the filter paper as well as the level of the solvent? Good. Actually, you would notice that the level of the solvent is below the line that is drawn on the chromatography paper, right? So we say that ensure that the sample to be tested or the line to be tested is above the line of the solvent here. Now, if the level of the solvent is above or on the stop line, it will then again interfere with the results, because it will dissolve. Alright, it will dissolve the sample, and the solvent cannot therefore allow the components of the dye here that you want to test to actually move up the filter paper. Alright, so you must make sure that before you start the experiment or chromatography process, the line of the solvent must be below the pencil marking line that you draw. Then we can say that, okay, your experiment is good to go and it is accurate, and we are able to rely on the results that you get at the end of the experiment. Okay, so now let's talk about how you can interpret your chromatogram. Now remember what is your chromatogram? We mentioned earlier on page 11. Okay, your chromatogram is actually the paper result with the pigment spots. Okay, so it's basically the filter paper that you get with the colored spots at the end of your experiment. Now, it is important for you to interpret a chromatogram because this will be a commonly tested question in WA2. So you will notice something. Remember just now Miss Lee mentioned that chromatography is based on the principle that different substances dissolve in different extents. So technically, we are talking about the keyword known as solubility. So we know that different substances have different solubilities in because they're different substances. So obviously their solubility will also be different. So if we look at um, figure 1, this is the starting point of chromatography where you can see I dotted a sample onto the starting line. Now remember, the starting line must be drawn in pencil, and look over here, the solvent level in the boiling tube must be below the starting line that is drawn in pencil. Now, once you dip the filter paper in, alright, the boiling tube with the solvent, you must give it some time because the filter paper will actually allow the solvent to be absorbed into the filter paper, and therefore the solvent will travel upwards. Now, when the solvent travels upwards, the solvent will actually dissolve this pigment here. And as the pigment dissolves, and as it moves up the filter paper, there will be colored spots. Now, these colored spots basically indicate or give you a clue on the solubility of the substances present in the mixture. Okay, so you can see that in diagram number 3, you can see 3 spots. Spot number 1, spot number 2, and spot number 3. So what does it tell you? If I say that the solubility of a substance enables it to travel further up the chromatography paper, that means the spot that is below travels the least, right? That is why it's very near the line. The spot that is the furthest travels the most. Now, if the spot is able to travel the most, that means this is a substance that is the most soluble. And because it's the most soluble, that is why it can be carried up the filter paper the most. Okay, that's like saying if you compare runner 1 versus runner 2. If they have to run the same race and runner runs and runner run 1 only ends up at the 150 mark, whereas runner 2 actually ends up at the 1.5 kilometer mark. And this is done within 15 minutes. What does that tell you about runner 2 compared to runner 1? Yeah, very good. You guessed it right. Runner 2 actually runs faster than runner 1. So what does this spot actually tell you about the solubility of spot 1 or substance 1 compared to the solubility of substance 2 or 3? Okay, so it tells you that substance 3 is probably most soluble in this solvent as compared to substance 1. Alright, so let's have a look at, you probably have to fill in this point. Okay, so therefore, the more soluble the substance in the solvent, the further it will travel up the chromatography paper. So let's have a look at this diagram over here at the bottom, nicely illustrates what Miss Lee has been trying to say. So you can see that in this chromatography paper at the starting point, alright, this particular mixture is made up of 2 dyes, a blue dye and a red dye. Now you would notice that as this dye, okay, dissolves in the solvent, you can see that it starts to separate, right? Can I ask you a question? Which of this dye in this last part of the diagram here seems to be separating and moving further away from the other dye? The blue dye, right? So that tells you that the blue dye is more soluble in this solvent as compared to the red dye, and therefore it will travel further up the chromatography paper. So please take note of this. Please use your highlighter and highlight, alright, that the more soluble the substance, the further it will move. So this is the least soluble and this is the most soluble. So the most soluble substance will travel the furthest upwards the chromatography paper, whereas the least soluble will stay closest to the original starting line. Alright, okay, so let's move on to the next part. All right, I would like to actually show you this short animation. So let me show you when I start the experiment. Okay, so I'm going to adjust your blue dye properties. So let's say I want my blue dye to be very easily absorbed, and the solubility will be the most soluble. And my yellow dye will have the same absorption level as the blue dye, but my solubility of the solvent will be very low, relatively lower than the blue dye. So I want you to think very carefully, what will be the relative positions of the yellow and the blue dye in the chromatogram. Now, when mixed together, blue and yellow will give you green, and that's why we see a green starting a green dot here. Okay, so we want to separate the blue and the yellow dye from the green dye. So I'm going to set the experiment, and I want you to notice what actually happens in this animation. So you notice the solvent moving up. Can you see the separation of the blue dye? Okay. And look what happens when the solvent reaches the maximum height in the chromatogram. Now, do you notice that the blue dye seems to be separating and traveling further up the chromatogram as compared to the yellow dye? Now, why is that so? Based on what Miss Lee has set the parameters here, you would notice that the blue dye is actually very soluble in the solvent as compared to the yellow dye. So you can still see that the blue dye is actually moving up the filter paper much further and faster as compared to the yellow dye, and the yellow dye is actually remaining quite near the original line because the solubility of the yellow dye is actually very low. Okay, all right, so let's move on. Now, there are three examples of paper chromatography in real world context. The first of which is actually identifying food colorings in chromatography. Okay, so for example, you can see here there are pigments in plants, dyes in paints like we saw just now earlier, right? We wanted to check whether this particular dye, this green dye actually is made up of the blue or the yellow dye. So sometimes you may have an unknown paint substance, and a particular factory may want to determine the different dyes that is present inside this paint. They actually turn to paper chromatography to do so. Alright, so you may want to arm yourself with your highlighter. Okay, so we actually identify food colorings. Now, these food colorings can be colorings in food, can be colorings that are found in paints, can also be pigments that are found in plants. Now, why do we use paper chromatography to do this? Because we want to ensure, or AVA, which is an arm of HSA, Health Science Authority in Singapore, wants to make sure that no harmful colorings are used in food. So what they will do is that they will use a predetermined set of dyes, okay, and they will compare the chromatogram paper. Okay, they will compare the chromatogram paper to these particular positions of the harmful dyes. Now, if the harmful dyes and these pigments in the chromatogram are at the same level and same height, it means that, this particular food that you are eating actually contains the banned substance, all right? Okay, so that is one example that we use paper chromatography to do to ensure that no harmful colorings are actually used in our food. Now, the next real-world application of paper chromatography is used to identify dyes in ink. Now, this can be done in forensic science. For example, if let's say in a murder scene, there is a letter that is written in a particular dye. Okay, a particular ink, and we are not sure as to who wrote that particular ink. So what we will do is that the labs will actually run paper chromatography to identify, the different inks in this particular, or the different dyes in this particular ink. And then they will compare this particular chromatogram to maybe a few different suspects' pens. So if there's a suspect 1, suspect 2, and suspect 3, alright, so they will compare the particular ink that is used by the suspects to this particular chromatogram. And if this particular suspect's ink matches the chromatogram, then we are quite sure that this person was probably at the scene of the crime. Okay, so that is a second That's a second application of chromatography. First is to identify food colorings to ensure that no harmful colorings are used in the food, or to identify banned substances. Okay, this also allows you to disprove if certain companies are using toxic substances. Secondly, we also want to identify the dyes that are used in your pen inks, and this is what your forensic scientist actually does to identify certain suspects in certain crime scenes. Okay? Last but not least, we want to also use chromatography to determine the purity of substances. Alright, so a single spot on the chromatogram means that the substance is pure. Alright, so if you look over here, you can see that there's only one spot here, right? So this one spot means that this dye has moved up to this position. But if you look very carefully here, you will notice that there are two spots. So why are there two spots here? That means this particular food dye is actually made up of substance 1 and substance 2. So this particular green substance here is an impure substance because it consists of two dyes. Whereas in this particular chromatogram, this black dye is a pure substance because it only contains a black dot. That means whatever substance that is here has moved up to this position to form this colored dot here. Okay, so a same thing, this is used to identify forbidden or harmful chemicals in your food. Alright, so now let's move on to your concept map on page 20. What have we learned today? Let's summarize. We have learned that paper chromatography is a very good separation technique that is used, okay, to determine the purity of substances based on their solubility. Okay, so therefore we can separate pure substances of different solubilities. Now let's link this to chapter 3. We learned that solubility is the amount of solute that can be dissolved, right? So therefore we know that different substances dissolve to different extents in different solvents. Okay, and one particular industrial application of paper chromatography is basically to find out the particular dyes that are used in ink or food, and this will allow HSA or AVA to determine if certain banned substances or toxic substances are found in your food. Alright, so now at the end of this, I hope that you can complete exercise 4.1, pages 57 to 61 for your homework. Alright, we will congregate again in the next lesson to go through your theory workbook. Okay, thank you.